We're going to prove the alternate interior angle converse in this video. So if you remember last time we were proving lines were parallel. We can show that lines are parallel 4 different ways. We can show that they're parallel using the corresponding angle postulate or any one of these theorems, where alternate interior angles are congruent, alternate exterior angles are congruent, or consecutive interiors are supplementary. Okay, so this is for section 3.3. We need to prove those 3 theorems so we can use them. Now, we are allowed to use the postulate right now to prove this theorem. So we need to prove the alternate interior angle converse, which means we're given congruent alternate interior angles. Can we somehow show that line G and line H are parallel to each other? Okay, so step 1 would be angle 4 is congruent to angle 5. That's given. Now the next thing you need to do is recognize the relationship that angle 1 and angle 4 have. I'm going to write it like this. Angle 4 is congruent to angle 1. What kind of angles are those? They're vertical. So we're using the vertical angle theorem to show that they're congruent. Now, if you have 2 different angles that are congruent to the same angle, what do you know about those 2 angles? They're congruent to each other. That's the transitive property of congruence. So we just showed that angle 1 is congruent to angle 5 as well. Well, those are corresponding angles. And if they're congruent, the postulate says that the lines are parallel. So if you do it this way, you could be done pretty easily. Line G is definitely parallel to line H because we just proved that corresponding angles are congruent. That's the converse of the corresponding angle postulate. Okay, so we just proved this theorem. That means we can use it anytime we want in other proofs. In this one, we're going to prove the consecutive interior angle converse. And this one's a little bit different, which is why we're going to go over it. So you are given that angle 1 and angle 2 are supplementary to each other. That's how you start to prove the theorem, because these are consecutive interior angles. You need to show that if they are supplementary, then somehow these lines are parallel. And this one can get a little bit tricky. It can get a lot of steps in it as well if you're not using the proper shortcuts. Okay, so we're given that angle 1 and angle 2 are supplementary. I look at the diagram and I notice also that angle 1 and angle 3 are supplementary. You remember what that's called? That's the linear pair. Ooh. Oh. How about I just write it? Linear pair postulate. Ooh. You notice the 2 angles in the diagram make a linear pair, so you can say that they're supplementary. Now, what happens when 2 angles are supplements of the same angle? That means those two angles are congruent to each other. That's a really important theorem that saves you a ton of steps. That's the congruent supplements theorem. If you didn't use or utilize this theorem or learn it when we went over it, you're going to be in for the long haul proving this. What you're basically going to be doing is proving this congruent supplements theorem inside of the proof of this theorem. Okay, so we just showed that angle 2 and angle 3 are congruent. Well, if they're congruent, those are corresponding angles. What does that do to these lines? It makes them parallel. That's the converse of the corresponding angle postulate.